We're going to continue working with the normal distribution curve. What we're going to do is we're going to look at a different word problem. Remember, there's two different ways that we solve these. One is we start with an x, we move to a z, and then we end up with a probability. The other method is we start with a probability, we move to a z value, and then what we do is we solve the x value based on how the question is worded. So what we have is we have an intelligence test scale, and it tells us that the mean score is 35, and we have a standard deviation of 6. So that's our key information that we need. And notice that it says normal distribution. In order to solve these, it's always going to say normal distribution. That's how we know we use the normal distribution curve. So whenever it says normal distribution, we know that we're going to be using this formula. Z equals x minus the mean divided by the standard deviation. Now, it says what number represents the 75th percentile. Notice it says what number. We're trying to find an x value. They give us a percentile. So we know we're going to be starting with our percentile, which is 0.65. So we're going to go inverse norm of 0.65, and that's going to give us a z value. So we take out our calculator, we do inverse norm of 0.65, and that gives us 0.385. Now remember, we're using the z equals formula. This is now a z value. We converted our p value into a z value. Now we're setting it equal to x minus the mean, which is 35, divided by the standard deviation, which is 6. Now when we're solving this, we first times the 6 by our z value, and then we add the 35. And when we do that, what we get is an x value of 37.3. Now, since it says the 65th percentile, we want a value where 65% of the people are below us. So that means that we are going to round up to 38. So we would need a 38 on this score in order to solve it. If you end up putting 37 because of the rounding rules, that would be acceptable too. Now for the next one, what number represents the 90th percentile? Once again, it's saying what number, so we're solving for an x. Notice they give us a percentile. So we're going to use the inverse norm of 0.9. We're going to take our p-value, we're going to convert it into a z-value, and it gives us a z-value of 1.28. That's the 90th percentile. We set that equal to x minus our mean divided by our standard deviation. Now, remember, in order to solve it, we take the 6, we times it by the 1.28, and then we add the 35. That right there gives us an x value of 42.6. And then because of rounding rules and us wanting a percentile being everything's below it, we're going to round up to a test score of 43. Now, that right there is a new material. What we're going to do for C and D is we're going to go back to what we worked on yesterday and what we talked a little bit about today. Notice it says, what is the probability? So we're going to the old method. What is the probability? So that means we're given an x value. So notice that it's in between 28 and 38. So that means that our x value is in between 28 and 38, which means that our z value is in between two values also. So we have 28 minus 35 over 6, and we have 38 minus 35 over 6. That right there gives us two z values, negative 1.17, and it gives us 0.5. I'm going to use the normal CDF. I'm going to put my least value, then my greatest value, and I'm going to come up with my probability. So normal CDF, negative 1.17, comma 0.5. And that right there is going to give me a probability of 0.5. 0.570. This next one is going to be similar. The reason that it's similar is it's in between 41 and 44. So our x value is in between 41 and 44. That means we want a z value in between 41 minus 35 over 6 and 44 minus 35 over 6. With those two z values, we're going to simplify them, and what we get is 1 and 1.5. And we're going to be using the normal CDF. We're going to put in our least value first, our greatest value second, and we're going to convert the z value into a probability, which when we plug it into the calculator gives us 0.09.